Okay, we're gonna try and give this a shot here. On page 20, we have two more carbonyl compounds to look at. Esters, which I'm gonna do last because they're probably the most challenging. Not hard, but they're just different. I want to go skip to amides first. It was going to be the last thing to name, but since I'm not there, I'd rather do the esters last. It's similar to an ester, but instead of COR, it's specifically CONH2. And it's really no different than any other thing we've seen. Just what's next to the carbonyl. This time it's an NH2 group. Find the carbon chain length and drop the E like usual and add amide as the suffix. So here we are again. 1, 2 carbons, so ethane, drop the E, ethan, amide, ethanamide. ETHAN AMIDE. Okay, so ethanamide. And similarly, I'd like you with your smush pair to do these two right now. Pause. And we're back. You've got butanamide here, BUTANAMIDE. And it's just butane, but drop the E, butanamide. And this one is, you got a little crazy here. 1, 2, 3, 4, 5, 6, 7, 8, octanamide. So octanamide is the last example here. So again, amides, no numbering ever needed because the NH2 group is always on the end of the chain. There can't be anything on the other side, so there's no issue. Esters, if you notice, are a little bit different because there is this COO group similar to the organic acids, but instead of there being an H over here, there's another hydrocarbon chain. And so that's going to make the naming rules a little bit different because it doesn't have to be, and it never is actually on the end of the chain. And the way that it gets named is a little bit different. So instead of COOH on the end, it's COOR. Like it could be COOCH3 or COOCH2CH3. That's how esters will look in condensed structural formulas. If you want to see what I'm talking about, look at number 25 on the organic review. I know I'm asking you to change positions here. Keep this page going, but look at the number 25 on the organic review. You'll say it says which compound is an ester, and look for the one that has the COO and then another organic group on the other side, and you will see indeed that that is choice, well, I'll let you do it, 4. Okay, that's choice 4. Choice 1 is an alcohol. Choice 2 is an acid, COOH. Choice 3 is an ether, with just an O in the middle. And choice 4 has the CO, which is the carbonyl, and then an O with another hydrocarbon group, CH3COOCH3. And so that's how number 25, choice 4, is an ester. So how do you name it? That's really what this is about. Let's take a look to table R. That's probably a good place for us to start. Maybe we can learn something from that. So esters, I'll zoom in a little bit because we're only going to be looking at one of them right now. Okay. Esters. Now they say that this monstrosity here should be called methyl propanoate. Let's piece that together. So methyl, we need a 1 carbon something. So I'm looking for a 1 carbon. That's a 3 carbon. That's the prop part. Okay, there's the 3 carbon part. And then here's the 1 carbon part. Okay, there's a methyl group actually. So the first part of the ester name right here is from the part that is bound directly to the oxygen. That's the methyl right here. And propanoate comes from the part that has the carbonyl. That's the prop. Notice the COO, CH3. That's important. You need both the oxygens here to be an ester. Otherwise, you've got a ketone. If you just have a carbon on each side, it's just a ketone. So you have to be here with a COO. But then this is propan, and instead of oic acid, like it was here, it's now O8. If anybody remembers the adic-itis thing from acids and bases, it's actually what this is from. You don't have to remember that, but if you do, awesome. It'll make sense for you. So the rules for esters seem to be, from this example, and this is how I want you to use table R, seems to be that you name the part that's on the oxygen first, methyl, with a space, and then whatever's left, propan, drop the E like usual, and then O8. That's how you name it. So name the substituent off the oxygen, and then name the rest of the chain with 8 as a suffix, or O8, I guess, O-A-T-E. So this one, let's piece it together. So here we've got, here's the part off the oxygen. That's the part you name first. That's a methyl. And then over here is only 2 carbons, so ethanoate. So as opposed to the one in table R, which is methyl propanoate, this one in your notes just has 2 carbons over here, so it is methyl ethanoate. Now, esters are used a ton in scents and flavorings. Methyl ethanoate is not really much of one. It's really the smell of glue. However, these other two are more common smells that you might notice. I want you to, well, I'll help piece together the second one, and then I want you to do the third one on your own. This one I'd like you to get in your groups of 4, which you're going to be in anyway for the next set of things. So press pause for a second, get in your group of 4. I take it you're back now. Good. And I want you to look, and I'm going to help you piece this one together. So remember, the first part of the name, you look at the thing off the oxygen, which is here. And the second part of the name, you get right here from the carbonyl side. Don't forget to count that carbonyl carbon. That counts. Press pause. Try and work through that. Okay, so I'm just going to do this one now. So the first part is off of the oxygen. That is a propyl group. Propyl. And this part is ethanoate. Ethanoate. Okay, it's not terribly hard. It's just different. Propyl ethanoate, again, 2 words, propyl, and then ethanoate is actually the scent of and flavor of pears. And I think we've talked about this before, but when they say natural flavoring, and let's say a piece of pear candy or something, natural flavoring means that it is the molecule that is in the natural thing. Like this is, in fact, the molecule that's in a pear. Doesn't tell you that the pear flavor came from a pear. It can be made in the lab as long as it's the actual molecule responsible for the flavor. That is called a natural flavor because it is naturally occurring. It may not be naturally derived. That would cost more money, and you can buy things like that. But when it says natural flavors, it does not mean that it is from the plant itself. It just happens to be the actual molecule found in nature. It may have been made in the lab. All right. With your group of 4, I want you to work through this one. I'm not going to tell you where to start. I want you to just get me an answer, so press pause and do that. Okay, I assume you're back. And the answer to this is ethyl butanoate. Ethyl over here, butanoate from the 4 carbons over here. Ethyl butanoate smells and tastes like pineapple, and it is used in a lot of pineapple flavorings. So that is an ethyl butanoate. Okay, that is all the names of the carbonyl compounds. I have left you with other assignments with the substitute for the remaining of the time, the remaining time you have in the double. I hope this has been useful. I hope that you got most of it. The videos are obviously on YouTube, so you can watch them again if you need to. And I will see you guys soon. Thanks so much.